Hi guys, so today I'm going to be teaching you how to read, write binary and how we can translate binary from denary and from denary back to binary. So first thing I'm going to cover is how we read and write binary. So I'm going to start off by making a 8-bit binary number. So we'll go 1 0 1 1 0 1 1 0. Is that 8? Yeah, it is. Okay, right. So this is an 8-bit binary number. This is just because we have 8 units here. So each one of these is called a bit. If we had 4, this would be called a nibble. That's an N. A nibble. And all of this put together is called a byte. So there is 8 bits to 1 byte. And there is 4 bits to 1 nibble. Which of course means there's 2 nibbles to 1 byte. That's an M again. Okay, so that's how bits work, that's how we can translate them to bytes and nibbles. So now let's actually understand what this means in the context of numbers and storing them. So with base 10 denary, what you and I read and write in, so we'd have a number, let's say 258, just arbitrary number. So of course we can understand that this means there's 2 100s, 5 10s and 8 1s, because if we wrote this out in its place value format like this, we could see that we have the 1s, the 10s and the 100s. The reason that we jump from 1 to 10 to 100 is because we have 10 symbols, which is 1 to 9, so we multiply by 10 each time, and that gives us our next column. So if we didn't understand denary as simple as we do, and we want to work out how much this was, we could just see that there's 2 100s, there's 5 10s, and there is 8 1s. So we go, that's 200, this is 50, and that is 8. If we added all these up together, we get 258. Now with binary it's fairly similar, it's not too hard to grasp. So let's give ourselves the number 14. Can represent this with 4 bits. So let's go make our place value chart with 4 slots, and we start with 1 again, but now because we're only working with 2 digits, the 0 and 1, we multiply this by 2 each time. So we go from 1, 2, 4, and then 8. Now this is where binary gets a little bit more difficult than denary. Of course, we're not multiplying by anything other than 1 or 0 in these columns here, so it's more additive than multiplicative down here. So what we would do is we go from left to right when we're making a binary number, and when we're reading it we go from right to left. So once we're making this, we have our number 14, and we can see 14 is bigger than 8, so what we do is we add a 1 here and then we minus 8 off our 14. We're left with 6, so we can see we have a 4 here and a 6 here. What we do, a 1 and the 4, and we minus 4 off the 6, we're left with 2. We have a 2 now, and we can represent 2 with just a 1 in the 2's column. We minus 2 from that, and we're left with 0. Of course, 1 is bigger than 0, so we don't need to take away 1 from the big number. So we can just put a 0 here. So this is how we would write 14 in binary. We'll just do one more example. So if I said, let's make 9 in binary, we'd make our chart again. Go 1, 2, 4, and 8. So 9 is bigger than 8. Minus the 8 from the 9, we have 1 left, so of course 4 is too big, 2 is too big, 1 is, well, 1 minus 1, we're left with the 0, so that's good. 1 in the 1's column. Another way you can read this is you could just say, okay, well I need these to add up to 9, so I'll just do an 8 and a 1. It's much quicker that way. Of course, once you start to get into bigger bit numbers, it can be a little bit harder to do on paper, of course, but it all comes down to practice. So now we know how to write a denary to a binary. Let's do a binary to a denary. So if I give the example of 1, 0, 0, 1, 1, this is a 5-bit. So all we do now is we write our place value, 1, 2, 4, 8, and 16. Now, there's 2 ways we can do this. I'll show you both, but I prefer the second method to this. We can do 1 times 16, because there's a 1 in the 16 column, or 1 times 2, because there's a 1 in the 2, and a 1 times 1 because there's a 1 in the 1. Put these all out. Of course, they're a number because they're multiplied by 1, and put them all together, and we get 19. Another way to do this, which is just way easier to do, is 16. Check the next column as a 1 in, as a 2, or plus 2. Check the next column as a 1 in, plus 1. And that gives us 19. So that's how we can write 19 in Denary from binary. That's, to be honest, pretty much it. But it does get a lot more complicated for numbers that aren't just whole positive integers. It does get a lot harder with negatives. Don't make it too much harder. But those negative numbers and floating point numbers I'll cover in a separate video because they are just so wildly different to this. And this is more of a beginner's video into binary. So I will leave it at that for now, and I hope you have a great day. Goodbye.